Welcome back, Algebra students, to Chapter 1, Section 6. Represent functions as rules and tables. This year we're going to see many types of functions. We will graph different kinds of things. Lines, exponential curves, U-shaped, quadratics, and so on. So today we're going to talk about how we know whether a group of points is a function or not. So to begin with, any set of group of points, any group of points is called a relation. Some relations are functions, some relations are not functions. They're just groups of points that you could plot, right? In order for a group of ordered pairs to be a function, there needs to be one something for each something. And we've talked about this in 7th grade as well. So one output for each input. Now recall that an input is the independent variable, the x in most cases. So the input represents the domain. All of the x values are the domain. The output then are the dependent variables, the y's. So depending on what x you put into an equation, what number you choose to put in, out pops a value for y. All of the y's together represent our range, which is another term we've used in the past. Let me just put a basic equation down, like y equals 2x. Okay? So again, we can choose any value to input for x. So it's independent. Give me a value like, let's say, how about a negative? I'm going to make a little table here. Let's put in -2 for x. When we do, we substitute -2 in for x. What is -2 times 2? That's right, -4. Okay. We could then plug in anything else. How about a 0? Plug in a 0 for x. What is 2 times 0? Out pops the y. So the y depends on the x you input. Let's put one more in. How about 4? Okay, so we plug in 4 for x. 2 times 4 is 8. And so now we have a domain that includes 3 values. And the domain values are -2, 0, and 4, right? The range are these y values, -4, 0, and 8. Okay. Let's look at a list of relations, a group of relations, and see whether they are functions or not. Remember, any group of ordered pairs is a relation. So looking at this, I have in my domain 1, out pops 3, 2, 4, 3, 5, 4, 6, 1, 3. Is this a function or not? Well, the definition again was one output for each input. So the best input to look at to prove this to be a function would be 1 because it was input twice. Now when we put 1 in the function here, we get 3. When we put 1 in the function again, what did we get? 3, that's right. So is this a function? Yes, this is a function. Okay? Let's try the second group. We have 1, 3, 2, 3, 3, 3, 4, 3, and 1, 3. This is a strange looking function, or not, a relation, let's say. Is it a function? So once again, we can look to the domain, we can look to the value that was input twice. When we input 1, out pops 3. When we input 1, out pops 3 again. So the output is the same for the same input. So is this a function? Yes, it is. It's a function. How about relation 3 here? Is this a function or not? You may need to pause and take down these numbers. Once again, we have 1, 2, 3, 4, and 1 as our domain. And then we have 2, 4, 6, 8, 10. That feels like a pattern. Functions often do feel like patterns. Is this a function? Go ahead and jot your thoughts down. Okay, now let's check. Input 1, and we get exactly 2, right? input 1 again, and we get 10. So, are we getting the same output for the input of 1? No. So if I input 1 again, what am I going to get? Am I going to get 2? And will I get 10? Or will I get 18? I don't know what I'm going to get. So this is not a function. The same, each domain must have exactly one output. So this is not a function. And the last example, pause and come back and check your work. And what did you determine? Is this a function? Strange looking range. But when we look at the value 1, it has an output of 2. When it was input again, it also had an output of 2. So yes, this is a function. Good. Now, people often ask, what if you didn't have 2 inputs that were the same? Like, what if I raise this screen up and we just have this list? 1, 2, 3, 4, and 2, 2, 3, 3. Would you say that's a function? We would say yes, because there's no proof that it's not. Isn't that interesting? In order for it to not be a function, you need proof that it's not, as you see in this particular relation here. Okay, so when we use functions, when we're working with functions, there are different formats we can find them in. We can write a verbal rule or have them in a word model, right? We can write a function as an equation, or we might see ordered pairs in a table, or even just in a group of parentheses, right? So let's see if we can write the rule for this, write the equation and create the table for this verbal rule. The verbal rule is that the output is twice the input. Okay, so we just make a quick table and provide some inputs. These are independent, so I'm using 1 through 5. We could have used anything, right? Those are all independent. If the output is twice the input, maybe the easiest place to start is completing the table. If the output, y, is twice the input, x, what would the output be when x is 1? What is twice 1? That's right, it's 2. So we would have 2. If we input 2, what is twice this input of 2? 2 times that is 4. And so on. We're just simply multiplying the input by 2, aren't we? So 6, 8, and 10. So now, when asked to write the equation, we know we're dealing with 2 variables, right? So we know that x is the independent variable, so we're operating on it. And y is the dependent variable. So we can start with just a little model like this. Y equals what's happening to x, right? What operation was happening to x to create the output in each case here? And if you recall, we named that operation. And so can you complete this equation? Good. We said we simply multiplied the input by 2. So the equation is y equals 2x. Okay? And there we have 3 ways of describing a function. Okay, let's pause the video here and see if you can write the function rule, the equation, in other words, right, for this group of points. Pause, come back when you're ready to check your work. Okay, be sure you have all the information in your table. And now we're looking at our inputs, 2, 5, 7, 8. And we're saying, what are we doing to the input? What operation are we performing on the input that leads us to the output? And I bet you have it. How is 2 related to 14? The first thing you might have thought was 2 times 7 is 14, right? So now we check and see if that would be the operation used in the next point, right? Is 5 times 7, 35? 7 times 7, 49? Is 8 times 7, 56? And if it is true that that operation gives us each output that we're looking for, then we have our rule. And so we can write it as y equals 7 times x. Awesome job. What fun, huh? Okay, have fun. Be sure to check your work. Be efficient. Do a good job. I'll see you tomorrow.